Right, dear students, so today we are going to discuss the 2023 advanced level networking question, that is question number 6, right? So when it comes to this question number 6, the networking question, they have asked to draw a sketch to show how a file server, that is FS, a printer P, a switch S, and two components C1 and C2 should be connected in a star topology. So they are asking to draw a sketch. So I wanted you guys to draw this with me itself, then it's easy, you can get an idea. So it's very easy. So you can establish a switch here, that is going to be the S, right? So the S is going to be the switch. Then you can connect the two computers, which is the C1, then the C2, then the C2, right? Then you can connect the file server, which is the FS, the file server FS, and then the printer P. Right now this is one way of answering. We are, according to the marking scheme, you will be getting the marks, or else now you can the printer could be connected to one of the computer as well, right? That means without connecting the printer to the network, this is one way. This is also right. Okay, you can take this to your writing book, or else what you can do is, without connecting the printer to the network, you can connect the printer to one of these computer. Either you can connect it for C1 or you can connect it for C2. So let me connect it for C1. Sorry, C2. Right, C2. Now this is also one alternative answer. Anyhow, if you have drawn one way, either you can connect the printer to the switch, connect the printer to the switch directly, or else connect the printer to one of the computer, you will be given the full marks, right? We are done with that. Now under question number 6, the B, a port number is also used along with an IP address in a network communication, that is why. So that is why is because it identifies the process that is relevant to the connection. So that is the reason why a port number is also used along with an IP address in a network communication. You can say that it identifies, right? This is the answer for A. Then for B, you can write it down. It identifies the process that is relevant to the connection. That is one of the reasons. Or else you can say it identifies the service point. That is also one possible answer, right? That is a theoretical question, very easy. Next, let us go for C. They have given, consider subnet with the network address. They have given 192.168.56.128/26 CIDR notation is given, where the 26 bits bits represent that 26 bits are allocated for the network bits. They are network bits, net bits. So now the question the examiner is asking, write an example IP address that can be assigned to a host attached to this subnet in dotted decimal notation. So let us try that question, right? So very easy question they have tested. So let us try that. Right. Now they have given 192. Okay, dear students, 192 dot 168 dot 168 dot 56 dot 128/26. Now this /26 represents the network bits. It represents the network bits. So there are 26 network bits here. There are 26 network bits here. Okay. So if I rewrite, you can say 192.168.56.128. Now how can you write this 128 in binary? That is very simple. That is 1 0, then remaining will be zeros. 1 2 3 4 5 6 7 8. So 1 2 3 4 5 6 7 8. So first bit is 1, remaining 7 bits are zeros, right? Then that is going to be 120. Now here you have 8 bits. Here you have 8 bits, right? Here you have 8 bits. Then here another 8, 8, 16, 24. Then here another 2 bits will be allocated to the net. So altogether here there are 26 bits. There are 26 bits. Then remaining, right? This portion is the number of host bits. Host bits. I hope that is clear, right? So if you make all these host bits, all the 6 host bits to 0, right, you will be getting what address? You will be getting the network address. So if you make all these 6 host bits into 0, you will be getting the network address. Then let us make that and try now. Okay, so how to find the network address? So here, let me do this here, network address. So the net bits are going to be the same, so no change in that. So here we will be getting 192.168.56. Now here 10. This 10 is what? These 2 bits also belongs to network. Okay, belongs to the network bits, net bits. Okay. Therefore, this 10, which is representing 128, also will be the same. There is no any change. So this is going to be the network address. This is going to be the network address because we have made all the remaining 6 host bits into 0. So there is no any confusion there. Now, if you want to find the broadcast address, what should you do? You need to make the remaining all 6 host bits into 1. So if you make all the remaining 6 host bits to 1, I mean these 6 host bits to 1, you will be getting what address? You will be getting the broadcast address. You will be getting the broadcast address. So let us make that. So here, let me bring this here. Let me bring this here. So it is going to be like this. The network bits are going to be the same. There is no any change. Okay. So it's going to be 192.168.56.10. The net bits are going to be the same, and the remaining 6 host bits are now going to be 1. Why? We are going to find the broadcast address. So 1, 2, 3, 4, 5, 6. Now here, when you do the conversion here to decimal, let's come for there. Here it's going to be the same, 192.168.56. Once you convert this into binary, we will be getting what? We will be getting 191. We will be getting 191. So this is going to be what address? This is going to be the broadcast address. So here you have 128. Okay. Here 64 won't come. 32, 16. 32. Here 16 will come. 8, 4, 12. Then 2 and 1 here will be 3. Now just do the addition. 10, 16, 17, 18, 19, 20, 21. So 2, 4, 5, 6, 7, 8, 9. Then here 191. So that is how you are getting 191 here. Now what is this address, dear students? This is the network address. Sorry, the broadcast address. Broadcast address. Okay. So you can write down the broadcast address here. So see how easy it is. Very easy. Directly ask. 192.168.56.191. Now this is going to be the broadcast address. Now what is the question the examiner is asking? Write an example IP address that can be assigned to a host attached to this subnet in dotted decimal notation. Now the examiner is not asking the network address or the broadcast address from you. The examiner is asking an IP address that can be assigned to a host. That means what? Usable IP address. So the usable IP address can be in what range? Right, it can be the range. The IP address can be in the range from 192.168.56.120. Can you allocate that for a host? No, that is for the network address. 129 to 192.168.56.191 is the broadcast address. So one before that, that is 190, the usable IP address, right? 190. So your answer, the examiner is asking only one. See, only one. Write an example IP address that can be assigned to a host attached to this subnet. So it can be from 192.168.56.129. That is also one answer. It's one example, no? Or else you can write this, or else you can write anything within this range inclusive of these two as well, right? So let me say 134, which is in this range. So you don't need to do this thing. What is the examiner asking? The examiner is asking to write an example IP address. So let me say 192.168.56.100. Let me say 134. You can take anything which lies between this range, in this range, inclusive 129 and 190 as well. Right, that is done. Now what is the examiner asking next? So that is the answer for C. C1. So we have started the 2025 revision series. So if you can join, you can join. We are doing a good program where you can achieve your dream of getting an A pass. Write the first and the last usable host address in this network in dotted decimal notation. We have found that, students. What? See, 192.168.56.129. That is what? That is the first usable host address. We have found the answer for that as well. So you can directly take that. For the second one, first usable. So let me do that up. Okay, do that up. So let me erase this stuff. Right, so let me erase this stuff because and now the first address, you can say the first usable address here, students. First usable or else just write it as first address. They are asking what first and the last usable host address. Okay, fine. First usable, you can say like that, or else directly you can say first address. It doesn't matter. First address you can say 192, or else you can say first usable first usable host address, right? You can say. So let me say first address is what? 192.168.56 dot what? Here 129. Then last usable address. So that is what, dear students, we have already found 192.168.56.190, right? 190, 56.129, 56.190. First usable address 192.168.56.129, and last usable address is this. We are done with that as well. Very easy. So that is the answer for what? C. Second one. C. Second. Now let's move forward. So do this with me itself, then on it's going to be useful. How many host addresses are available for using this subnet? How many host addresses are available for using the subnet? That means what? Usable host addresses. Now here, dear students, already in the previous scenario we have found there were how many host bits? There were 6 host bits. No, there were 6 host bits. Okay, 6 host bits were there. Now you know 2 to the power 6. 2 to the power 6. That is 64. But remain always, you need to keep in your mind, the examiner is asking what? Host addresses are available for using the subnet. That means what? Usable host addresses. That means you need to deduct 2 from here. Deduct 2. That means what's the answer? Answer is 62. Answer is 62. So you can see here the answer for the third one, if I am right, is how many host addresses are available for using the subnet, that is 62. 62, right? 62 is the answer. So very easy question they have tested in the 2023 networking question. Now let us move to the next question. Okay, so let me erase this stuff. Right, okay. So next question, D. Suppose an internet service provider, which is the ISP, owns the 192.168.56.32/26 IP address block. Assume that the provider wants to create 4 subnets. How many subnets to be created? 4 subnets. Keep in your mind. 4 subnets. Alright. Then name the subnet A, subnet B, subnet C and subnet D from this address block, with each subnet having the same number of IP addresses. So each subnet is having the same number of IP addresses. Okay, fine. So let us take the ISP, the IP address block that is given by the ISP, that is 192.168.56.32/26, right? /26. So this is given in CIDR notation. So this 26 represents number of network bits. Very easy to remember. Okay. Now what is the thing they are asking? The first one, D. First, write the subnet mask of the above given IP address block in dotted decimal notation. That means what? You need to convert, you need to consider all the network bits. So all the network bits are going to be 1 when you are focusing on the subnet mask. So 26, no, this first 8. Here 192 is formed using 8, first 8. So those first 8 is going to be 1. Make every 8 bits 1. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8 dot. Then here also 8 bits are going to be 1. 1, 2, 3, 4, 5, 6, 7, 8. Then here also 8 bits are going to be 1. 1, 2, 3, 4, 5, 6, 7, 8. Now here you have 8. Here you have 8. Here you have 8. So 8 plus 8 is 16. 16 plus 8 is 24. Now here another 2 also will be net bits. Then only it is going to give you 26. The remaining 6 bits are allocated for the host. So 1, 2, 3, 4, 5, 6. Right? Okay, fine. Then now you need to convert this into what? Convert this into decimal. Very easy. Done and dusted there. Okay, so let me erase this stuff. Right. Then here, once you do the conversion, here you will be getting 255. Here you will be getting 255. Here 255. Here, once you do the conversion to binary to decimal conversion, you will be getting 192. What's the answer? This is the answer. This is the answer for the first one. That is 255.255.255.192, which is the subnet mask. Let's move forward. Write the number of host bits needed to create the required number of subnets. Now, how many subnets you need to prepare or you need to create? That is 4 subnets. So when you are writing the exam, you need to focus or highlight these things. Okay, 4 subnets. Now we know how many. Now we can create subnets using what? Using host bits. Now we know there are 6 host bits here. Look here, there are 6 host bits. So out of those 6 host bits, how many bits are needed to create the required number of subnets? Very easy. 2 to the power 2 is what? 4. See, how many subnets you need? You need 4 subnets. So 2 to the power 2 is 4. Then how many bits? That is very easy question. That is going to be 2 host bits. The answer is 2 host bits. Okay, done and dusted. Extra. Once subnetting is done, fill in the following table. They have given a table format. So let us quickly take this to your writing book. Do with me itself. You also now open the book and take it to your writing book. Then on it's going to be useful at 2024 advanced level ICT exam, right? Otherwise, no use. At last moment, you can't do anything. Okay, do it now itself. So let me erase this stuff here. Okay, right. Let me keep this as like this. Fine. So let me have the table here. So first of all, we are going to have the subnet, dear students. Subnet. Then we are going to have the network address. Then the first usable IP address. Right? Then the last usable IP address. Then broadcast address. So this is the format the examiner has given you. For the format should be the same. You can't do any changes to the format because the examiner has specifically given you a format. You can't play your game when the examiner has given. You need to follow the same format. So subnet, if you like, you can follow, but you will be losing marks. You won't be given marks. Marks will be deducted. So make sure you adhere to the same format. Right. So do this. So this is the thing you need. So here subnet A. So here let me say subnet B, then subnet C, subnet D, right? Okay, right? Okay, fine. Now here. So dear students, now you know here. So this 26 bits are allocated for the net. We know that, okay? And here, so that means if you all these 26 bits are allocated for the net. So these remaining bits were allocated for the host bits. Okay. Now out of this, so there is now out of these 6 host bits. Now we have allocated 2. Now we have allocated 2 bits for what? 2 bits for the network subnets, to make subnets 2 to the power 2 or 4. So these 2 bits were allocated. Right. Now if you convert this 32 and write it in binary, what will you get? You will be getting here 0 0 0 0 1 0 0 0 0 0. So see how many bits are there? 3 4 5 6 7 8 bits are there. What you need to do, you know, this 32, take this 32, convert it into binary. So 0 0 1 0 0 0 0 0 is going to give you that. Okay. Now we know this is also previously was allocated for the net. Now to form the subnets, we gave 2 additional host bits. That means these two additional host bits were given to make the subnet. These 2 host bits were given. So you know previously, dear students, we had 6 host bits now. So then we wanted to create 4 subnets. So out of in order to create 4 subnets, we had to give 2 host bits out of 6 host bits. Okay. So after giving that, now the remaining host bits are going to be 4. Because previously held 2 host bits were given to make the subnet. So you need to be crystal clear on that. Okay. So then what did I do? I took the 32 and converted it into decimal. Sorry, binary. I took the 32 and I have converted the 32 into binary. So once you convert here, you know, 128, 64, 32, then all the remainings will be 0. Only this will be 1. Okay. Yes, 0 0. Then it's going to be 0 1 1 0 and 1 1. Right. Now here you had 6 host bits previously. You had 6 host bits previously. Out of those 6 host bits which you had previously, you gave 2 to make subnets. Now bits, when you are finding the network address host bits, all the host bits are going to be 0. So here remaining 4 host bits will be 0. As simple as it is. As simple as it is. So here you have 2 net bits you had previously. That is not going to change. That is going to be 0 0 itself. That is going to be 0 0 itself. Okay. So let me have that 0 0 0 0 0 0. Now do the conversion. Okay. So if you convert this into decimal, 0. If you convert, this is the first network address. Then the second network address, if you convert that into decimal, you will be getting how much? You will be getting, so first of all, let us take that. So here 192.168.56. Here 0. That is the first network address. So see the second network address. The previously held things are not going to change. But see the subnet mask, the 2 bits which you gave to make the subnet mask will be changing 0 0 0 1 1 0 1 1. That means this is the first one, second one, third one, and fourth one. That's the combination. Okay. So once you convert this into decimal, you will be getting 16. You will be getting 16. That is the network address here. 168.56.16. Then convert the third. Here, convert this into decimal, then you will be getting 32. Then you will be getting 32. So 192.168.56.32. That is the third network address. Then the last one, that is going to, once you do the conversion to decimal, you will be getting 64. You will be getting 48. Sorry, you will be getting 48. 32, yes, now here 1, 2, 4, 8, 16, 32. So 16 and 32, 8, 48, you will be getting 48. So 192.168.56.48. Now to find the broadcast address, how you need to find the broadcast address? Now you know there are how many remaining host bits are how much? 4. Previous you had 6, but out of that you gave 2 to make the subnets, no? So out of, now you have only 4 host bits. So then if you need to find the broadcast address, what you need to do? Make all the remaining host bits into 1 when you are finding the broadcast address. As simple as it is. So now let me make all the remaining to 1. Why? To find the broadcast address. These things are going to be the same. Those are net bits. No, there is no any change in that. Right? There is no any change in that when you are considering the broadcast address. Okay. So the first one is going to be how much? That is going to be 15. So once you convert 0 0 0 0 1 1 1 1 to decimal, you will be getting 50. You can do the conversion and get, but no need. Why? You can do that in a simple way. I will show you how to do that. Now look here, 192.168.56.0. That is the first network address. Second network address is .16. Beginning with .16. Then the previous broadcast address should end with what? .50. Then no need to find no. 192.168.56.50. Here 16 means there are 50. And here 32 means here 31. The remaining front one won't change when you are finding the broadcast. So 192.168.56.31. As simple as it is. Here 48, then they are 47. 192.168.56.47. 47. Now here last one, as because you don't have this, you can do the conversion only for that. Okay. Here once you do the conversion, that is 0011. Let me take here 0011. See 1111. So once you do the conversion, you need to convert this binary into decimal. Then you will be getting 63. You will be getting 63. So here 1, 2, 4, 8, 16, 32. 32 plus 16, you can do the calculation here. Okay. 32, then 16. Yes, 16, 8, 12, 14, 15, 15, 6, 8, 9, 10, 11, 12, 13, 4, 5, 6, 63. Yes, 192.168.56.63. So done and dusted, very easy. Now first usable IP address, what? Network address is .0 means first usable is .1. So 192.168.56.1. Now I have done 2018 past paper, 2000 I think 19 we did, then 2023 also now done. So you can if you haven't watched them, you can watch those things as well. The last one usable IP address, this is broadcast is .15 means the last usable IP address must be .40. 192.168.56.40. Then here 16 means here 17. Now you can do it, beat me, pass me and do, okay. Dot 17. You have taken this to your writing book now, okay. 192.168.56. Here dot 30 because the broadcast address is dot 31, so last usable IP address deduct 1 get 30. Here 32 means first usable is at 133. 192, the fronts one are going to be the same, 168.56.33. Then here 192.168.56.46. Then here 192.168.56.49. Here 192.168.56.62. Yes, 49, 62, 33, 46, 17, 30, 1, 40. Okay, we are done with that. Okay. So now write two functions of a proxy server in a computer network. So I am erasing this. Let me go for the E one. Right. That is E, theoretical question. So you need to have some sort of a knowledge in theory. We also have started the 2025 revision. So the students who wish can join and ensure your A pass. Write two functions of a proxy server in a computer network. So what is that? You can say storing recently requested web pages for future requests. Okay, now recently if you are viewing some web pages, those things will be saved. That is one. Storing recently requested web pages for future requests. Or else it acts as an intermediary between the user's computer and the internet. Right? It acts as an intermediary. That is also one of the function of proxy server. Or else you can say allow client computers to make indirect network connections to other network services. That is also fun. One. So I told you 3. The examiner is asking 2. So you can write 2. So you can say acting. First of all, say acting as an intermediary between the users computer and the internet, right? Or else you can say storing recently requested web pages for future requests. That is also one answer. Then let's move forward. Second one. What is the question? Write two properties of MAC address assigned to a device connected to a network. Yes, very easy theoretical question, straightforward. So there are 48 bits in length. Okay, so if you take, there will be 48 bits in length. That is one. And they are physical addresses. And always you can say they are assigned by the manufacturer. So two properties now. So let us say first of all, there are 48 bits in length. Next you can say they are assigned by the manufacturer. Right, that brings the end of 2023 network past paper discussion. Thank you.